All right, so there's not really a whole bunch new outside of what we talked about yesterday or on my previous video. The main thing about this is understanding asymptotes and also understanding the rules of vertical and horizontal asymptotes.
I'm
Um,
gonna look for that.
so you're gonna look for it. You want to say hi to them?
Hi. Hi.
Tell them your names.
My name's Jasper. My name's Oscar.
Okay.
I'm 6 and I'm 5. And I go to school and my teacher is named Mrs. Turner Smith. That's her long name. And her short name is Miss Smith.
What did you tell me earlier about how people feel about their teachers?
Good.
Is that what you said? But what did you say before?
Uh-huh.
No, you don't remember. I thought you said that like everybody likes their teachers.
Yes.
Yes. So did you guys hear that? Everybody likes their teachers.
Mm-hmm.
So thank you. All right. Can I keep telling them about asymptotes and stuff?
Yeah.
Okay.
My name's Oscar, and my teacher is Wesley, and my helper teacher is Miss Logan. And
Do you like them?
yeah.
Mm. You got anything else to say before I keep going?
No.
Okay. Should I tell them more about rational functions and stuff? Okay. All right. So anyway, so you do need to know how to find horizontal asymptotes and vertical asymptotes, and this is, definitely domain. The first question on the quiz is basically going to be like something from, where are they? Like 1 to 6, like something like that is going to be, you're going to be asked about that. Like I said before, something like 19 to 22 is going to be asked. And then a lot of this other stuff that we're going to talk about is going to get wrapped up into one big question about graphing a rational function. Okay, so a lot of this is going to be lead up to that. And so the first part of the lead up to that is 24 and 22 here. It says find the zeros, if any, of the rational function. And they don't really specify whether those are zeros on the x-axis or on the y-axis. So we can find both. Well, I guess hold on, I'll just check to see what they're looking for here. Okay, it looks like they're just talking about the zeros on the x-axis, and I guess usually that is what a zero implies, is that you're on the x-axis. But you find it the same way as of any other function that you're given. You want to replace and we'll look at 24 here. You want to replace the y value with 0. And solve. Okay, so you guys have all these rules built up, and you have to know how and when to apply them. Looking at this, we do have a quadratic, so we're probably going to have to get them all equal to 0 at some point, but it's down in the denominator, so the first thing I'm going to do is subtract the 4 over. And then I'm going to multiply by x squared plus 2. Then I'll add that 4. Oh, I'm sorry. I'll divide by that negative 4. And then subtract the 2. And so when you're subtracting a 2, right, I'm going to get a common denominator there of 8 over 4. Okay, so then we have x squared equals negative 13 over 4. And of course we take the square root of that, and we're going to get the square root of negative 13 over 2. And so now we have these imaginary numbers. So then plus or minus I radical 13 over 2. Okay, so those are imaginary zeros. That means that this is not going to cross the x-axis at all. All right, so let's take a look at number 26. Okay, so again, we're looking for the zeros, so same process, set the y value equal to 0. That's what is true about any x-intercept. I'm going to use the same idea as I did in the previous example and just multiply by x squared plus 1. Of course, anything times 0 is 0. So then we're down to x cubed minus 8. And a lot of times people will say, all you have to do is set the numerator equal to 0, which is true. But the reason is that when you multiply by that denominator, they just go away. So then adding the 8 to the other side, we have x cubed equals 8. Take the cube root of both sides, and that would give us 2. So then the x-intercept of number 26 would be 2, 0. Okay? So I'm just going to read through 27. That's a good problem to think about. I'm not going to actually do it, but I want you to understand kind of what's going on. So it says, right, consider a physics laboratory experiment designed to determine an unknown mass. A flexible metal meter stick is clamped to the table with 50 centimeters overhanging. Okay, so right, this is 50 centimeters here. And known masses, okay, so we know what they are. Here they are, right, are attached to the end of the meter stick. For each mass, the meter stick is displaced vertically, so it bends down, and then is allowed to oscillate, so up and down. The average duration t in seconds of one oscillation. So one oscillation would be down and then up, down. So up, down is one oscillation. Up, down is one oscillation. The average duration t in seconds of one oscillation is for each mass is given. Okay? And so then what they're asking you to do, they say a model of the data is given. This up here is real data that they collected by doing their experiment. And then they say, okay, this is just a model of that data. And it says, use this model to create a table showing the predicted times for each of the masses shown in the table. Okay, so again, what we're talking about here, sorry about all that, is this is experimental data. This is the model that represents this data. So you're not, and then they're saying, okay, take this data and plug in these m values in there and see how close we are to the actual stuff. Okay, and then it says, what can you conclude from that? So, okay, so experimental data by the model that is used to predict what these seconds would be. Okay, so I think you guys can figure that out from there. Okay, so I'm not going to do anything with this. I'm just going to point out that we've done this a bunch, and this goes back to that idea that I want you guys to be able to think of what these shapes are generally, and be able to apply and kind of get an idea of what you're looking at. So I'm not going to sit here and tell you that, oh yeah, you need to know exactly where all these lines are, but I do want to point out, if you know that this is 2 over x that makes this shape, we can use our translation ideas to come up with the rest of them. Okay, so for instance, this is subtracted on the inside. So, the inside being the x down here. So still, as it always has, something on the inside is left and right, but in the opposite direction. So this will look exactly like this, except shifted 1 to the right. This one will look a little bit different, right, because of the 2, so it's being, divided by 1/2. So that, will make it wider, is one of the ways we thought about it. And then shifted to the left too. Okay, so that's what you're doing with those. So I'm only gonna do one more problem here. And I'm gonna pick one of these to kind of go through, and let's just do, I don't know, 30, we'll just do 38, okay? And you see what they're being asked. They want a sketch of the graph, and as sketching aids, check for intercepts, okay? And so X and Y intercepts, symmetry, vertical asymptotes, and horizontal asymptotes. Okay, so I'm going to go to the next page, and they got this little chart that we're supposed to follow. Okay, so guidelines for graphing rational functions. Okay, so let me get the function that we're going to look at here. Okay, so I'm just going to step through each of these steps, okay, and then we're going to make a sketch of the graph, and then we can take a look at what it actually looks like and see how good we did. So step 1, find and plot the y-intercept, and I'll just try to plot everything all at once. Well, maybe I can fit it in here somewhere. Okay, so find and plot the y-intercept by evaluating f of 0. Okay, so then this would be like step 1. So p of 0, right, we're going to substitute in 0 for any x value. Okay, so then there's step number 1. We found the point 0, 1. Okay, so good. All right, we'll plot that here in a second. Find the zeros of the numerator, if any, by solving the equation p of x equals 0. Okay, so this is kind of what we started with. Okay, so then, oh shoot. So right, so then we have, so this is number 2 here. So then 0 equals 1 minus 3x over 1 minus x. And like they said in the step number 2, it's really just the numerator, because again, if we multiply by the denominator, it's gone. So then we have 0 equals 1 minus 3x. So 3x equals 1. And x is finally 1/3. Okay, so we got another point that we can look at. 1/3, 0. Okay, step number 3. Hold on. Step number 3. Step number 3 says find the zeros of the denominator by solving the equation q of x. So we're talking about the denominator, setting the denominator equal to 0. And so if you remember what we're doing here, so step number 3, is we're locating any vertical asymptotes. So then we have a vertical asymptote at x equals 1. Okay, and I think I'll just plot all this out at the end. 4, find and sketch horizontal asymptotes, if any, by using the rule for finding horizontal asymptotes. Okay, so we have to check out our degrees. Notice the degree in the numerator and the degree in the denominator are the same. So that means we take the leading coefficients and put them over each other. So then -3 over -1 is 3. So we have a horizontal asymptote. At y equals 3. All right. And now they're saying, okay, you get all this stuff on the graph and then plot at least one point between and at least one point beyond each x-intercept and vertical asymptote. Use smooth curves to complete the graph beyond, between and beyond the vertical asymptotes. Okay, so then let's see what we got so far. All right, so this isn't going to be super, super wonderful, but I'll try to get it as good as I can. All right, so we have, let's see, let's start with, let me put the vertical asymptotes on first. So we have x equals 1, so we have a vertical asymptote right here. We have a horizontal at 3. Okay, and so at this point, I'm going to say that, usually things happen, these have to be, they still have to pass the vertical line test. So you're probably almost never going to have something in these two areas or in these two areas. So maybe here and here, or maybe here and here, or here and here, or here. Excuse me, here and here. Okay, so, but let's see what other information we have. We have a y-intercept at 1, so we got that. And we have an x-intercept at 1/3. Okay, so then we're right here. Okay, so then what's going on here, and this, there's going to be a little sketch like this. So we got that point, and now they're saying, all right, well, pick, one on the other side of the x-axis. Pick one being another x value. So we're going to pick something pretty easy and see where it falls on these compared to this horizontal asymptote. So we got one more step we got to do. So then let's just pick something easy, right? We'll just pick 2 and plug it into our function. Hold on. So then we have a coordinate of 2, 5. All right, so let's go back to our, right, so then 2, 5 would be about right here. And so then it's going to be basically this shape now. All right. And so then that covers all of our guidelines. And so you're going to have to do that, but let's check to see what that actually looks like. Okay, and so here is the Desmos version of what we just did, and so we match up pretty good, huh? All right, so give these a try. You guys get to 45. Do your best. I'll see you guys soon. You want to say anything on the way out?
Bye.
All right, you gonna tell them what we got to look at now?
Bye.
Say, do your homework.
Do your homework.
Yeah. Tell them these are basically going to be on the quiz.
These are going to be basically on the quiz.
All right, good job.
Good job. Good job. Good job.